Every single day, we look up and see a beautiful blue sky. But have you ever stopped to ask yourself, why is the sky blue? Many people believe the sky is blue because it reflects the oceans. It sounds like a reasonable explanation, but it's actually not true. Think about the Sahara Desert. It's covered nearly 9.2 million square kilometers. There's no ocean anywhere nearby yet. The sky above the Sahara is just blue. So, what really makes the sky blue? The real answer begins nearly 150 million kilometers away at the sun. Sunlight takes about 8 minutes and 19 seconds to reach Earth. Every single second, the sun sends billions of rays of light toward our planet. Flashes through a prism, and that white light splits into 7 colors: red, orange, yellow, green, blue, indigo, and violet. You can also see these 7 colors in the rainbow after it rains. But the sunlight we can actually see is only a tiny part of everything the sun emits. It's called the visible spectrum. The part of the sun radiation that the rays can detect. Light travels in waves. Each color has a different wavelength. The longer the wavelength, the closer the color is to red. And the shorter the wavelength, the closer it is to violet. But before sunlight reaches your eyes, it has to travel through Earth's atmosphere. Think of the atmosphere as a vast ocean, made of countless tiny air molecules that are invisible to us. Most of the molecules are nitrogen and oxygen. When sunlight interacts with these tiny molecules, a phenomenon called Rayleigh scattering takes place. The molecule absorbs the light generally and then scatter it in every direction. But not all colors interact with air molecules in the same way. Blue and violet light have much shorter wavelength, so they scatter far more strongly than the other colors. In fact, the amount of scatter decreases in this order: violet, indigo, blue, green, yellow, orange, and finally red. That doesn't mean the other colors disappear. They continue traveling or march straight from the sun toward Earth's surface. Blue light, however, keeps colliding with air molecule and is scattered over and over again. After billions of scattering events, blue light is spread throughout nearly every part of the atmosphere. Imagine you standing on the ground. When you look up at the sky, you're not looking directly at the sun. Instead, your eye receives blue that has been scattered throughout the atmosphere. That blue light reaches your eye from every direction. And that's why, no matter where you look during the day, the sky appears blue. But if both blue and violet lights are scattered so strongly, why isn't the sky violet instead of blue? There are 3 main reasons. First, the sun emits much less violet light than blue light. Second, as sunlight passes through Earth's atmosphere, a large portion of the violet light is absorbed by the ozone layer and the upper atmosphere. That means much less violet light is left by the time it reaches our eyes. The biggest reason lies is our own eyes. The human eye contains about 6 to 7 million cold cells, the photoreceptor responsible for detecting color. Most people have 3 types of cold cells. L codes, about 64%, most sensitive to long wavelengths. M codes, about 32%, most sensitive to medium wavelengths. S code, about 2% most sensitive to short wavelength. Even though violet light is scattered more strongly than blue light, our eyes are much less sensitive to pure violet light than they are to blue light. So when you combine all 3 factors, there is less violet light in sunlight to begin with. Some of that violet light is absorbed by Earth's atmosphere, and the human eye is much less sensitive to violet than to blue. As a result, the sky appears blue, not violet. But here's another fascinating question. Why do the sun and the sky turn yellow, orange, or even deep red during sunrise and sunset? At this time of day, sunlight has to travel through a much longer path in Earth's atmosphere before it reaches our eyes. That means the light must pass through a much thicker layer of air. Along this longer journey, most of the blue and violet wavelengths are scattered away before they can reach us. Only the long wavelengths such as yellow, orange, and red continue traveling to our eyes. That's why sunrise and sunset often appear golden yellow, orange, or deep red. If the air polluted during the day and contains large amount of dust, smoke, or aerosol, these particles enhance a phenomenon known as mist scattering. As a result, more blue light is scattered or blocked, making the sun or even the sky appear yellow, orange, or even red, even in broad daylight.
Earth-observing satellites continuously monitor the amount of dust and aerosol in the atmosphere.
They do this indirectly by measuring how sunlight is scattered and absorbed. Using the measurement, scientists can estimate the concentration of airborne particles. This information helps forecast air quality and assess whether the air is safe for people to breathe. Overall, a blue sky is generally a sign that the air is relatively clean and healthier for us to breathe.